Find the gradient of the chord PQ drawn to the curve fx equals x squared plus 2 in this diagram. Now, what I'm going to do is I'm going to say this line, this graph is called fx, and that fx name is, that function is x squared plus 2. Which means to find a y value anywhere here, all I have to do is substitute the x value. So when x is 1, I put in 1, put in there, and I find out what is y's value. If x is 0, I put in 0, and then I see y equals 2. So this graph, that is the function to find y. What they ask us now, and we're not going to do the CAS calculator one, we're only going to do it manually. Or by hand. So what I want to do is I need to find what is the gradient of this curve. Now the gradient of that curve, going back to year 7 or year 8, m equals y2 minus y1 over x2 minus x1. Now what do we have? We have here, we have an x and a y, an x and a y value. And usually we're just going to say that's x2, y2, x1, y1. Now we have, the only value we have here is we have x1. So what I want to do is I want to know what is y when x is 1. And to do that, I need to substitute 1 into my equation. So I'm going to say f at 1 equals, and I'm going to substitute 1 in there, 1 squared, so wherever there's an x, I'm going to put a 1, and my answer equals 3. So when x is 1, y is 3. Then q is some h units away. I don't know what it is, so I'm just going to keep it that. However, I want a value here. I don't want a function here. So I also want to know what is f at 1 plus h. So to know what f equals 1 plus h is, I'm going to substitute, wherever I see an x, I'm going to put a 1 plus h. Now you're going to use a bracket. I see it's an x squared plus 2. What is x supposed to be? It's not x anymore, it's now 1 plus h. 1 times 1 is 1. 1 times h is 1h, plus another 1h is plus 2h. And h times h is plus h squared, plus that 2. Now I'm going to do this on the sideline just for those who don't know what it is. How did I get this value? Well, to find this value, what I did was I said 1 plus h multiplied by 1 plus h. 1 times 1 is 1. 1 times h is 1h, and 1h. So that is always double that term times that term. And then h times h is h squared. So that is where I got that from. I'm now going to simplify where I can. 1 plus 2 is 3. So I have h squared plus 2h. 1 plus 1 is plus 3. I can replace this now with this value. So this value here, 1 plus h, and I have h squared plus 2h plus 3. And all I'm going to do is I'm just going to substitute these values back into my gradient function, which is my gradient equals, and remember, gradient is the derivative of x equals the gradient equals, wow, that's a lie. It's not the derivative. It's not the derivative. Please, we're not finding derivative. The derivative will be at a specific point. This is just a gradient between 2 points. That's why we can't use this. Right, so the gradient is y2. y2 equals h squared plus 2h plus 3. Take away y1. y1 is 3. Divide by x2. x2 is 1 plus h. Minus x1. What is x1? x1 equals 1. I'm going to simplify that. Plus 2 and minus 2 cancel. So that cancel, plus 2 minus 3 cancel with each other. That didn't work. Plus 3 minus 3 cancel. 1 take away 1 cancel. So what I have is I have h squared plus 2h divided by h. I'm going to take out a common factor h at the top, which remains then h plus 2 divided by h. Because I have one term above and one term underneath, this h can cancel with that h, and my answer is h plus 2. That will be the gradient between those 2 points.